Okay, welcome to Lesson 79, Powers and Laws of Exponents, Part 4. So this is 4 in a 5-part series, so please watch all 5 parts, starting with Part 1. If you haven't checked out my welcome video, welcome to this channel, so you can learn how this channel works. Please watch my intro to numbers and operations video so you can know what topics are being covered in numbers and operations, and we'll get right into the lesson. Our objectives, our vocabulary, and here go all of the rules except for the identity rule. So let me write the identity rule for you. So we have an identity rule, which means x is understood to be to the first power, any number. Maybe I should have wrote base A and B since they have that in there. So let's change it from x to A. Any base A is understood to be to the first power. Okay. So now find the volume. So here's an example. Sometimes now you'll see pictures in things. Okay, so we have 5 to the 4th to the 7th power. This is actually a power rule. So if we were to expand this out, this would be 5 to the 4th 7 times. 4, 5, 6, and 7. So this is actually what this is. And so we know when we see exponent outside of a parentheses, we're going to multiply these exponents together. So 4 times 7 is 28. So this becomes 5 to the 28th power. And if you were to add all of these 4s up using the multiplication rule, you would get to 28 as well. Okay, so let's look at our second example. Now we're dealing with letters, but it's the same thing. So this 6 applies to the 2 and to the 3, because if we were to expand this out, it would be the same thing as the previous example. That's 3, 4, 5, and 6. And we know when we multiply from the first 2 videos, you just add the exponents, or when we raise a power to a power, we multiply. So we get 6 times 2 is 12. We get x to the 12th, and then 3 times 6 is 18, and y to the 18th power. So that's how you would simplify that. Now, you cannot combine the x and a y, and some people do this because they are different bases. So because they are different, the x and the y will be different numbers. You cannot combine their exponents. They remain separate. Let's look at example 3. So now, same thing as before. We multiply the -3 to both terms, and be careful when doing this. So -4 times -3 is 8 to the 12th. Times c. 5 times 3 is 15, -15. And now this becomes simplified, 8 to the 12th power over c to the 15th. And 8 to the 12th power is a large number. So what I'm going to do is calculate that for you. Okay, I calculated, and 8 to the 12th is too large for the calculator. It gives me a decimal times, it says decimal e to the 12th. So I'll deal with that when I get to scientific notation. You cannot do anything with this 12 and the 15 because the 8 and the c are different bases. So the right answer is 8 to the 12th over c to the 15th. And then this is all you can do. You cannot simplify it any further. Okay. So 4 squared over 4 to the 4th, 4 to the 2 minus 4 gives us 4 to the -2, which is 1 over 4 squared, which gives us 1 over 16. Okay. Those are our examples. Please meet me at the end of the video for a recap. Okay, now we don't see an exponent 2x to the fourth. These are different bases, so we have to separate them. The 2 and the x are separate. X will be a number, and there's no exponent on the x, so we have 2 to the 1. And so now we distribute the 5 to the 1 and to the 4, and we get 2 to the 5th times x to the 20th power. So be careful when you see 2x. Most people will only do the 2 to the 5, multiply the 5 to the exponent, and you'll get 2x to the 20th. But there is an exponent with the 2, and the 2 and the x are separate numbers, even though they are in the same term. Okay, so there's supposed to be a parenthesis around this one. Okay, so we got x squared over z to the 5th, and this is called the quotient rule, raising up power to a quotient. So 3 times 2, and then the 3 will multiply to the 5, and this will give us x to the 6th over z to the 15th. And they have a common factor of 3, so you can pull it out. So the one on the left is the more simplified form. This form is the standard form. But if you wanted to factor out an exponent, you could. So we may go backwards in another video. All right, so now we have 1/2 x to the -4th y squared to the 3rd power. And so we're going to multiply. So remember, do not forget that this 1/2 is its own number. So, and its power is 1. So we're going to have 1/2 to cubed x to the -3 times 4 is 12. And then y to the 6th power. And so let us do some fractional magic. So 1/2 cubed is 1/8. So we got 1/8 times 1/12 times y to the 6th, which is over 1. And if we combine them, we get y over 6 over 8x to the 12th power. Our last example. Okay, this looks a lot crazy, but there's supposed to be a parenthesis here. And so make sure we're dealing with the same base. So -2 and 3, since they're being multiplied, what we are going to do is add. -2 plus 3 is 1, so you get 3. 2 and 2 are the same base. We're going to multiply and use the multiplication law of exponents. 4 plus -1 is 3, so this gives us 2 cubed, all to the -1 power. So we get 3 over 8, because 2 cubed is 8, to the -1 power, which gives us 8 over 3. Because when you have a negative exponent, just basically flip your fraction upside down. And now 3 goes into 8 2 times with 2 left over, and the 3 stays on the bottom. And this is the final simplified form. So you have to keep going until you get down to a proper fraction, even though we have a mixed number. So this concludes this lesson of this series. Please watch the previous lessons and the next one, because this series is meant for you to watch all 5. And if you like what you see, subscribe and hit the notification bell. I apologize that I haven't said this in the previous 75 lessons. I do not want to assume that you're just automatically going to like what you see. But if you like what you see, please subscribe to this channel.